Hello, Olivia.
Hi, Errol. How are you?
Fine. Okay, we are on board. We are starting.
Okay. I see it's a recording, right? So
yes.
it's
yes.
There's no live audience, or
there is live
okay.
audience, but it is recorded, and then we introduce to the YouTube with your name and with the University Corporation.
Okay.
Okay. I welcome all to the blockchain talks of Istanbul Aydın University. Today's speaker is Mr. Olivier Ricken. He is the founder of Emerging Horizons and CEO of Leopard. And we can say for Olivier, he has a very long and distinguished CV, but we could make it like a very short summary. We can say he is one of the best blockchain, smart contract, and governance expert. I know he is also expert in DAO, but today he will talk about DAO, Distributed Autonomous Organization, and tokenization. So, Olivier, first of all, thank you very much. I know you are in the middle of your holiday, but
no, it's not holiday actually. It's work, but
good place, St. Bart's.
Yeah.
Okay. So the word is yours.
All right. Thank you very much. Errol, thank you for having me. I thought this morning how international we are, because we met in Latvia, if I remember correctly. Cool. I am based in Amsterdam. I'm right now in the Caribbean giving class in Turkey. It's the way the world works now. So that's always great. But let's get started, and I'll share my screen. Can you please make sure that I can do screen sharing, because I prepared a couple of slides, obviously.
Okay.
And that always helps in supporting my story.
You can share.
Yeah, I can share now.
Yeah.
No, I've host disabled participants screen sharing. So for some reason, I cannot do it. But in meanwhile, if you try to work on the settings, I can briefly introduce myself. My name is Olivier Ricken, and thank you for the kind introduction, Errol. I've been busy in the blockchain space for quite some time. I think it's approximately 8-9 years ago when I first came into contact with blockchain. And I immediately thought this is kind of cool. So that's where I also actually start working or gave up my full-time career and start working in the blockchain space on a full-time basis. And just a little bit of my background: I am an engineer by background. I studied system engineering in Delft University of Technology, and I'm still affiliated to Delft University of Technology, where I do my PhD in the governance of decentralized autonomous organizations. And besides that, I did an MBA as well to understand more the business side of things, which always helps as an engineer. And I have various roles right now. So I'm working for Emerging Horizons, my own company, and for Ledger Leopard, which is the biggest blockchain implementation firm in the Benelux, working on day-to-day solutions, but also connected to the Dutch Blockchain Coalition, the ISO, etc., etc. And I do give a lot of guest lectures like this, and that's what I really like. But enough about me, because let's talk about the content. Let's talk about decentralized autonomous organizations, tokenization, etc., because that's the cool stuff, right? So let's get started on that one, and let's start out with a small thought experiment. What if the following was possible? What if it was possible that by filling in a few parameters on a website and clicking on OK, we can create an entity? And this entity can hold on to value, can transfer value, but also can organize, track, execute, and archive votes. And new participants can say, hey, I want to join this entity. And the current participants then have to agree to the fact that they can join. And once they do, they'd have voting rights in this entity as well. So a real open democratic entity system, basically. And it's very easy to put value into this entity, but to get the value out, the participants have to start voting again if the value is allowed to go out. So it's easy to get value in, but it's hard to get value out, at least one-sidedly, because everybody has to vote on this perspective. But we can vote not only on spending money, but we can vote basically on tons of things, like do we want a new strategy, or do we want an update in the rules of our governance system, etc. So it's not only tied to the transfer of value in itself. And what if we could actually create this entity with virtually no running or maintenance costs, nor employees, on a super secure, unstoppable network, or in other words, read a blockchain? And what if we could set this all up in under 2 minutes for approximately $15 to do so? And what if we could do that without the need of a notary, a lawyer, a trust company, a financial institution, etc., but completely do it yourself, and again, within a few minutes for a few dollars? That, at least to my opinion, can be a true game changer in a lot of things. And this is basically what we talk about with the world of tokenization, and more specific, the world of decentralized autonomous organizations, or DAOs in itself. And the world of tokens and decentralized autonomous organizations is obviously powered by blockchain. And before I'm going to tell a little bit more about tokens and DAOs, let's briefly, but very briefly, go into what blockchain is again, just to get the ground straight here. So blockchain, mostly connected to Bitcoin, and that's because everybody knows Bitcoin for some reason, and the reason is quite obvious. It's the oldest application ever built on top of blockchain technology, but blockchain in itself is not Bitcoin. Bitcoin is an application that uses blockchain technology. What is blockchain then in itself? Well, blockchain in itself is a technology that provides for an electronic public transaction record of integrity, which is a sentence that I almost literally copied out of the Bitcoin white paper, to be honest. And what does it mean? It's an open administration where everybody who wants to can join without ever having to worry that somebody else in this administration performs an action that he or she is not allowed. And the content of the administration is a content of integrity, or it cannot be falsified in itself. And that in itself is quite cool, that we can have an open administration that we can all trust. For example, if it's an administration where we keep track on how much money everybody has, which loosely translated can be seen what Bitcoin is, then you don't have to worry that I will spend your money, or because it's electronic, that I copied my money and double spend it in itself. And that in itself is quite cool, but this already existed. But what did blockchain make blockchain so unique in itself? Well, the uniqueness of blockchain in itself is that we can provide such an electronic public transaction record of integrity without the need of a central authority for integrity guarding of the content. And this is the real game changer. Not so much the electronic part, the public part, etc. That's stuff that we already had out there, but that we don't no longer need a trusted third party or a central authority to guard the integrity of a shared administration. And if you let that sink in for yourself, then you will see what this can mean in a lot of business models, supply chains, etc. Because we invented a lot of these central authorities or trusted third parties for the sole purpose of guarding the integrity of a shared administration over a supply chain or within an industry or whatsoever. That can be a bank, it can be a notary, but it can also be a quality assurance company that makes sure that you adhere to the right rules, etc. These are all central authorities that we created to guard the integrity of a shared database that is in principle accessible for everybody out there. So in essence, blockchain is a very special database that could rearrange the way we do business by eliminating a lot of parties in between. But this is not going to be a class about blockchain. It's going to be a class about the applications that we build on blockchain. So what can we do with blockchain then again? Well, there are three main uses for blockchain. And the first, obviously, is the transaction of value. And I deliberately say transaction of value because it's not specifically monetary value. It can be a monetary value, although it's a huge discussion if a cryptocurrency is a monetary value in itself, but it can also represent a stock in my company or a share in my house or whatsoever. You see whole new ideas coming up there. And we can start transacting this without the need of a trusted third party in between. So if I want to share 1 Bitcoin with Errol, that would be very nice this morning, by the way. It's approximately $55,000. Then I don't need a trusted third party, a bank or a financial institution to transfer this value to Errol. And we can create these tokens that represent this value, but we're going to go in tokenization later on in the presentation. The second thing is the secure data storage. And secure data storage, I mean not that the data is hidden for privacy reasons whatsoever, because everything is public and transparent in a blockchain. But secure data storage is what I mean with that is that the authenticity of the data is guaranteed. So once you store a data point in a blockchain, it cannot one-sidedly be altered anymore. And can it be updated? Yes, it can be updated, but then you basically put a new value over the old value and see it like a new sticker on top of an old sticker. And if you peel off the old sticker or the new sticker, you can always see the old value. You cannot delete the old value. You cannot alter the old value. So this is for secure data storage. And thirdly, since the rise of Ethereum and Hyperledger, we can use it to store logic. And this logic is what we call smart contracts in itself. And this ends up to 2 main pillars of use cases, being peer-to-peer transaction use cases and peer-to-peer evidence trail use cases. So using blockchain, we can transact value, data, whatsoever, peer-to-peer to each other. And we can peer-to-peer prove things to each other. And what do I mean with peer-to-peer? Every time I mention peer-to-peer is that we don't need a traditional third party anymore, that we need to guarantee a data point or guarantee that the data, the money wasn't double spent, etc., etc. And this can be done with or without logic, or with or without the use of smart contracts, or either simple versus complex. And if we plot that in a 2x2 matrix, we have a few ideas what that entails. So a simple transaction system is any cryptocurrency. I transact value from one person to another, no logic attached to it, but it's a simple, very clean-cut, very cool system because it creates whole new possibilities and it saves a lot of cost for the end user in the end. But it becomes much more cool if we can attach rules to it, and we can say, hey, but I'm only going to do this payment if certain conditions have met. So if for example, the ship has left the harbor, then I'm going to pay out 5% of the total trade amount. This is what is called a conditional payment. And this is typically something of a conditional transaction system. And this is what we can do using smart contracts. And I'll briefly go over smart contracts in a minute or two. On the evidence trail side, you see solutions like document hashing and self-sovereign identity, and where it becomes really cool if the evidence also then leads to the transaction of value due to predetermined conditions. And that's, for example, where decentralized autonomous organizations really hit in. So let's continue with these smart contracts, because the smart contracts are in the base of a lot of these solutions, not only decentralized autonomous organizations, but also in tokenized solutions. So what are smart contracts? Well, smart contracts, first of all, are confusing, is a confusing definition. And I reckon that probably most of you have never seen a smart contract before, because that's the general feeling that I have in my audiences. But this is what a smart contract can look like. It's just a piece of code. And this is literally code in a code language called Solidity, which is the smart contract language that we use on Ethereum. And Ethereum is by far the biggest platform to build smart contracts on. Around 99% of the smart contracts nowadays that are publicly available are built on Ethereum, or a knockoff of Ethereum, being XDAI, Binance Smart Chain, etc. But they all have the same core code to come down to. It's quite a confusing definition, because is it a contract or is it code? Well, in a lot of cases, it's just code that we deploy on a blockchain and it does something and it doesn't have a contractual value in itself. The second thing is it smart or is it dumb? Well, smart contracts live on a blockchain, and anything that lives on a blockchain is per definition reactive, because a blockchain is not proactive. A blockchain will only start doing things if it's called upon. So you need to send in a transaction request, and then the blockchain is going to do something. And that also goes for a smart contract. So a smart contract will only start to do something if it receives a message that it needs to start doing something. And then only it can do exactly as it is programmed. And that's what we call deterministic. So it cannot think for itself. It cannot think out of the box. It cannot scan the environment to see if something changed. No, it needs to receive a message, and then it can only do something according to its rules. So it's technically speaking not really smart. And in a lot of cases, it's not a contract, so it's not the best chosen name ever. Is it then completely useless? Absolutely not. So let me briefly explain a little bit more what makes a smart contract so cool. Because what is a smart contract from a technical point of view? A smart contract, and again, I'll adhere to the smart contract example on Ethereum because this is the most used platform for smart contracting. On Ethereum, it is an account. Just like you create your own account when you have a wallet and you open a crypto account, then you have your public address and you can start trading cryptocurrencies, tokens, whatsoever. Well, a smart contract is also an account. And that entails something very important. First of all, that as it is an account, it can hold on to value because it has a balance. So you can store value into a smart contract. But unlike your personal account, being your personal wallet, where you sign and then you send the transaction request and then you transfer value to somebody else, a smart contract does not have a private key, but it has its code. The rules that you basically say so the rules that you type are being deployed with the account. And these rules actually are the checks what happens to the balance on the one hand or to the storage on the other hand, because you can also store information on a smart contract. You can store a status of a particular voting, or you can store the coordinates of a ship that's sent through the coordinates through an IoT device whatsoever. But based on these rules, this code, the smart contract is going to do something with the balance or the storage. And as it is an account, it has its own address or a number or an ID. And or a specific ID name if you build it in Hyperledger. But what happens if I send a message to a smart contract? Well, then the smart contract is going to read its code, see if it can do something with the message. And if it can do something, it will either end up by either accepting value or sending out value from the balance or updating its storage, or it can even trigger an outgoing message to other smart contracts. So you can have a whole umbrella of smart contracts communicating with each other only by being triggered by one external transaction in itself. So why are these things so important? Well, that all has to do with the token side and the tokenization side. So I'll come down to that later. But first, I want to really make a distinction between cryptocurrencies and tokens. And these two are being used as one all the time, but technically speaking, they're something different. And there is a crucial importance in the difference between the two of them. A cryptocurrency is also called a native currency or an inherent currency. And a token is also called an issued asset, right? So what is a cryptocurrency then? Well, a cryptocurrency is always linked one-on-one to a certain blockchain. So you have Bitcoin on the Bitcoin blockchain, you have Ether on the Ethereum blockchain, etc., etc., etc. And the cryptocurrency only officially has two main uses. One, to reward the miners or the stakers, and two, for pricing the transactions. And rewarding the miners or the stakers is the security aspect of a blockchain, and pricing transactions is to make sure that everybody keeps on running the nodes, etc., because that's part of the earning model of the nodes. But I'm not going to go in through the whole economy of a blockchain system in the background. But basically, in order to create a cryptocurrency, officially you have to set up a whole blockchain protocol. So you have to set up a network of miners, etc., or nodes, whatever. But in order to create a issued asset or a token, that's a completely different story, because an issued asset or a token is made with a smart contract. So just by deploying a smart contract on the Ethereum network, you can create a token. And the purpose of that is not pricing of a transaction, not rewarding of the miner, so the security of that blockchain protocol. No, it can be anything you attach to it. So you create a token and basically you say, my token is going to be this, and this promise is what the purpose of the token is. And that also makes it really, really hard to classify what a token is from a regulatory perspective, but I'll show you that later on in the presentation as well. So I want to have this distinction very clear. In order to create a cryptocurrency, you have to set up a blockchain. In order to create a token, you have to deploy a smart contract. And to set up a cryptocurrency or a blockchain takes quite some time. In order to deploy smart contracts takes a split second. And that's easy, does it. And tokens are widely used, for example, for ICOs, STOs, IEOs, decentralized finance. This is where we use tokens for, not cryptocurrencies. Cryptocurrencies are hardly ever used for decentralized finance, etc. They're all issued assets built on top of existing blockchain protocol infrastructures. Yeah. So what are these tokens then? Well, we distinguish two main types of tokens. We have normal tokens versus NFTs. And you probably heard of NFTs last year. If you didn't, you lived under a stone, I think so, because everybody was talking about NFTs all the time. So what is the difference? Well, it's basically you have a normal token, and a normal token is created, for example, through the ERC20 smart contract. And this is where the tokens created by this smart contract, all the tokens are exactly the same. Compared, for example, with physical coins, say dollar cents, just as an example, or euro coins. Every euro coin is exactly the same and they're interchangeable. So the only thing that you arrange in a smart contract is the supply and if they're allowed to be minted, etc. But then the amount is there and all the amount of tokens, every single token in itself is the same and is interchangeable. So it can be used as a payment instrument or as a proof that you are allowed to vote, or it can be used as a share in your company, because share 1 and share 2, it doesn't matter, they're interchangeable if it's the amount that is important. The NFT side are the so-called non-fungible tokens. And non-fungible tokens are made with a different smart contract. They're made with the ERC 721 smart contract if you use the Ethereum blockchain. And this is here, like with normal tokens, you can create a whole batch. For example, the normal token, we create 1,000 tokens, but all the tokens are equal, are interchangeable. And with non-fungible tokens, I can create a batch of, say, 1,000 tokens. But every token has a unique, let's call it a serial number, right? So all these tokens are unique. So if you then attach this to some unique object, you can use it for a whole different purpose, where the tokens are not allowed to be interchangeable because there are on the background true differences between the various tokens. And I'll support that with a couple of examples. You can in both ways, like I said, you can create multiple tokens, but again, if you create multiple tokens with a normal contract, then all the tokens are the same. If you create multiple tokens with an NFT contract, then all the tokens are unique in itself, right? So, and then there's a new standard, by the way, that's called the ERC 1155, and there you can create normal tokens and non-fungible tokens, but you can forget about that. So what can we use tokens for then? Well, normal tokens, basically, we had this distinction between normal tokens and NFTs. And normal tokens, the fungible tokens, created by ERC20s or BEP20s, if you use the Binance Smart chain, are used for three main uses. For example, as utility token, it can be a voucher, and a voucher without or voting without any economics behind it, so that you don't have any economic gain for the voting in itself. Or it can be used as a payment instrument, for example, a stable coin, or it can be used as a security. And the security is, for example, an economic voting token, for example, like a share or a bond, or it can be used as a loan. The non-fungible token can be created with this ERC-721 or the EOSIO NFT if you use the EOS network. Basically, there you can use it for various purposes. For example, you can use it for, oh, I'm trying to hide my thing here, so you can see it a little bit better. You can use it for this NFT can represent art ownership or IP trading rights or access rights to a system. And if this token represents art ownership of an art piece, this obviously needs to be a unique token because they are not allowed to be interchangeable in itself. From a regulatory perspective, by the way, it doesn't matter if it's an NFT or a normal token, because for these kind of ownerships, it still can be seen as a security, a payment instrument, or a utility token itself, because this is kind of more a regulatory intake in itself. So let's continue with these tokens. And why is it so easy to create them? Well, through the use of these standardized token smart contracts. And that's why I started out with smart contracts. To create a token, it's so easy because we have all these kind of standards. We have the ERC-20 standard, we have the ERC-721 standard, and it's made so easy that it's 123 lines of code, but you only need to alter 4 parameters in order to create a token yourself. So if anybody ever says it's hard to create a token, they're obviously lying, because it's one of the most easy things to do. It's hard to create the platform and the surrounding and the regulation adhering rules around it. But the token in itself that you can start trading wallet to wallet with your friends is very, very easy to create. That only takes a split second. And here you can again see an example of a token smart contract. And this token smart contract, here you see, for example, the elements that you have to fill in. You need to fill in the token name, the symbol, and the amount of decimals that your token has. You hit deploy, and once you deploy it, that's it. That's all there to it. And during the deploy, you're given the supply that is being created. The difference between a normal token that you see over here and an NFT is in what we call this set token URI, or in other words, a uniform resource identifier. So per token created, you create a uniform resource identifier referring to a place where a certain object or whatsoever is stored. So if it's the ownership of a digital piece of art, then this URI refers to the place where the original of this digital piece of art is being stored, for example, somewhere on IPFS, what you can see in the middle here. And then by trading this token, you trade the ownership of this piece of digital art. This is how it works in itself. This is how NFT works. But you can also, for example, store the IP of a certain software product in this place, and then create an NFT on top of it. And the holder of the NFT is the owner of this IP right of the token in itself. So that is what makes it really cool. So what is it used for? Well, creating these tokens is being used for creating the whole decentralized finance world. And Errol only gave me 45 minutes, so I don't have the time to explain the whole decentralized finance world. But basically, it's the centralized finance world, but built on top of blockchain technology in a more decentralized way, which has a lot of pitfalls and challenges in itself. And I don't have the time to go over it. There are some very, very nice YouTube videos made by Finematics. Really look them up. This guy is really good in explaining all the DeFi world and the different products out there. But for example, what we can build are decentralized exchanges and derivatives that we know, stable coins, margin trading products, lending and borrowing products, and insurance products, but all in a decentralized way where we can start doing peer-to-peer lending and borrowing, or peer-to-peer insurances. And a good example, for example, of peer-to-peer insurances is a company called Nexus Mutual, which is truly peer-to-peer insurance, where people insure each other through a so-called decentralized autonomous organization, the cliffhanger for the next part of this presentation. So what are some of the pitfalls of tokens and NFTs? And there, I hope just by my sheer enthusiasm of the subject, you can see the possibilities that it's easy to create a token like this. You can start trading it peer-to-peer immediately. So it makes creating a system of transaction of value, whatever the value is, very easy. But there are some pitfalls and challenges as well. And I think the biggest pitfall with regards to normal tokens is that basically every single startup that I speak to, the first thing they always say to me, the token that we create is a utility token. And they will never say it like this, but they loosely translate that by our token is not regulated. And this is where I strongly disagree, because this is where even the new world hits the old world, and the fact that you can build a product in a way more efficient and cool way doesn't mean that a product in itself is completely different to start with. And this is a mistake that I see made by a lot of startups in itself. So if I create a token and I say, with this token, you get interest, and with this token, you can start voting on decisions in my company, you're gonna have a hard time explaining to the regulator that your token is not a share and that your token is a utility and being not regulated. While most of the startups say, hey, our token is cool and it's an ERC20, so it's not regulated. This is something you really, really have to be careful about. And that's also one of the reasons that I'm in the board of the so-called Two Tokens Foundation in the Netherlands, which does research towards the regulatory status of the different types of tokens, because there's a lot of misconceptions out there. So please bear with me. 99% of the people will say they create a utility token, while only in 1% officially most probably a utility token is created. And in 99% of the situations, you will most probably create a payment instrument or a security token. And if you do so, please contact your regulator what you have to adhere to if you basically publish in security in itself. But again, you can make it way more efficient than setting it up through the traditional way. So that is the cool part. The biggest pitfall that I see with NFTs at the moment is the duplication loophole. And the duplication loophole is basically twofold. First of all, if it's a NFT that was, for example, the representative of the ownership of a piece of digital art, how do I know that this is the original piece of the digital art and not something else, or that the artist copy-paste their JPEG 2 times and made 2 original JPEGs? Or how do I know that there were no 2 NFTs created on 1 JPEG in itself? So we have an original document, but, or an original JPEG, but 2 tokens were created there. And whomever I spoke to so far could not provide me with a solid answer how we can tackle this, other than with traditional legal means by guaranteeing this through various contract constructions or guarantees by the makers, etc. So this duplication problem or pitfall is really a pitfall in the NFT world. The 100% utility pitfall is a pitfall in the normal token world. And just to give you an idea of how complex this is, what a token entails, I made a little roadmap that we created for the Dutch law of what a token is in itself. And the first question is, how does your token classify using the ITSA framework? Is it a security token, a payments instrument, or utility? And if it's a payment instrument or utility or something else, do you provide advisory service? Yes or no? If yes, then you have to start digging into MiCA. If no, are you the creator of the token? If yes, then do you create a platform for creating or trading token? Because if so, you're basically a security platform and have to adhere to security platform laws. It is quite, I'm not going to go over everything, but this is basically the decision tree that it goes for the Netherlands. And every time you hit a yellow box, you have to knock at the door at a regulator, say, hey guys, I might be under regulation with this token. And the funny part is a lot of the regulators are still struggling themselves how to deal with it itself. And this also goes for the NFTs in itself, because you always have to think if this is something that falls under what on the left-hand side is financial regulation. And once you did the financial regulation, on the right-hand side, you have all different kind of other regulation as well you might adhere to. So don't think about tokenization from a regulatory perspective too lightly, because you could come into trouble in the long term. Let me put it like that. But still, there are huge opportunities because it's really easy and cool to create it in itself. And nowadays, all the token projects, literally almost all of them, are saying, hey, besides the fact that we have a token, we are organized in a decentralized way, or in other words, we are a decentralized autonomous organization. Every single project is calling themselves a DAO at the moment. So what are DAOs? Well, DAOs in very short, but I'm going to go over the definition a little bit more because that is a hard question to answer already. But to start, it's an organization where humans are basically placed at the edges and automation is placed in the middle. So the execution of a lot of processes is done automatically, and humans still have some involvement on the edges. And it was all first described not by Vitalik Buterin in this case, but by Daniel Larimer in 2013. But in the same year, Vitalik Buterin already took it to the next step. But the first description was around autonomous corporations, basically decentralized autonomous organizations that pay dividends. And then a few months later, Vitalik Buterin says, well, we can create organizations that not specifically have to be paying out dividends, but can be set up for multiple purposes and can be more versatile. And he basically then called them decentralized autonomous organizations. And then all of a sudden, just with smart contracts, a very interesting discussion started. What is the legal status of that? Which, to my point of view, is a very difficult question to answer. And I'm not totally agreeing with these guys, the limited liability autonomous organization people, saying that you need separate legal entities for DAOs. You might need separate legal entities for DAOs, but in a lot of cases, the purpose and the setup of the DAO in itself will most probably determine the legal status of the DAO in itself. But let's not go too far. But like you see, 2013, the first description ever of, hey, we should be able to build these kind of things. How fast did it go then? Well, in the beginning, it went quite easy. And as of 2018, we really see a flip in the amount of DAOs. And this amount you see over here, we can still debate about them, if they're real DAOs, yes or no. And I'll emphasize a little bit more on that during the pitfalls of DAOs in the end. But as of 2018, we saw one big change that happened, and that was the rise of the so-called parameterized platform deployment, parameterized deployment platform of DAO. I will say it wrong. It's a term I made up myself, sorry. But DAO, parameterized DAO deployment platforms. That's it. Yeah. So basically, by fitting in a few parameters on a website, clicking on OK, you deploy a smart contract or a series of smart contracts on a blockchain, creating a DAO. And examples of these platforms are Aragon, DAO House, DAO Stack. Colony is working on it as well. Basically, the platforms are coming up more and more and more, because prior to 2018, when Aragon started, you really had to hard code these DAOs yourself. So it was quite hard to create a DAO, and now it was made very, very easy. And that's what you see in these numbers. And that's why we see the steep incline of the cumulative amount of DAOs in itself. But what is a DAO then? And the definition in itself is really hard, because we do not have one overall definition. So together with my colleagues from the Delft University of Technology, we came up with the following definition, that the DAO is a system where we can store, where there's storage and transaction of value and notary functions in a decentralized way, etc. Oh, sorry, I can't go back. But let me briefly explain it based on this one. A decentralized autonomous organization is basically not a traditional organization with organizational layers, but it's an organizational being built up by smart contracts. and the execution of decisions and making of decisions is done by business rules that are embedded in the code of the smart contracts or by voting. So that is basically the notary function, and all the transactions are being recorded in a decentralized way, meaning they are being recorded on a blockchain. And basically has two main functions, being either a notary function and a transaction of value function. These are the two main functions of decentralized autonomous organizations, right? So this is what decentralized autonomous organizations are. So what are then some of the pitfalls of decentralized autonomous organizations? Well, first of all, how decentralized are they? A lot of decentralized autonomous organizations are decentralized in name. So we did a huge empirical research towards them, literally dove into thousands of DAOs. And it turns out that a lot of DAOs have 5 token holders or less. So how decentralized is it then? And in a lot of cases, there is one token holder who has a majority share who can basically call all the shots. Is it then decentralized? It's a discussion. I don't have an answer here, but it is a pitfall. How autonomous is it? Is a decision automatic being executed or not? In some cases, the execution of a decision is not automatically being pushed forward. So is it then autonomous in itself, or is it just a decision-making machine in itself? Another pitfall, and this is what I hear a lot as well in startups, saying we're going to set up a DAO because we do not want to fall under a certain jurisdiction, which is something you can never retract from. You will always be part of a certain jurisdiction based on the work that you do, where you do it, etc., etc. This is not the way to diverse jurisdiction itself. It can be an interesting discussion under which jurisdiction a DAO or the activities of a DAO will fall, but you will always have to adhere to certain jurisdictions. You cannot retract from that in itself. And finally, what is the right governance model to be set up? And that's a very interesting one as well. So you don't know yet what, and this is something that is still very much being researched at the moment. What is the right governance model that you need to use in order for a certain purpose of a DAO, etc. And the amount of governance models is growing and growing wildly at the moment. So you can pick your choices everywhere. If you go to aragon.org, you can choose out of 5 templates already for a certain governance model that you would like to use in itself. And then you just pick it and deploy it. For the interest of time, I'm going to skip this example and I would like to call it the day. It's exactly 45 minutes. So are there any questions? If so, please let me know.
I think there will be no questions, but I'm just waiting for the participants.
Yeah.
Raise their hand. I think we don't have it.
Okay.
So it means, as I said, you very well covered everything. And we are very thankful for your participation, because there was some points we can say, really, it's an open-ended situation, but your explanation, your ideas really open new horizons, as you are from the founder of the emerging horizons, new horizons in the blockchain issues. I would like to thank you and our participants on behalf of the Istanbul Aydın University Blockchain Academy. And we hope that we will have you again in the future as in person at our university. Thank you very much, Oliver.
I would love to join. Thank you very much for having me, and have a great day.
Thank you very much. All the best.
Yes, bye-bye.
Bye.